Hello everyone, welcome to day 5 of logic building in programming. Today we are going to solve a simple problem which is move the zeros to the end. Let's first understand this particular problem statement and we will move towards solving this problem. So let's say we have a array with elements 1, 0, 2, 3, 0, 4, 0, 1. What we need to do is move all these zeros to the end. We have 0 here, here and here. The final output would look something like this. We need to move all the zeros towards the end. So we have 3 zeros should move towards the end. Similarly, if we look on towards another example, this array contains 1, 2, 0, 1, 0, 4, 0. Here are the elements 3 zeros. We need to move this towards the end. So if you want to solve this problem at your own, do give it a try. And now onwards we will be actually understanding how to solve this particular problem. So to solve this problem there is mainly two approaches. One approach is using another array, and second way is to use two pointers, which is a popular way of solving problem in DSA problems. So first we will start with using let's say a copy array where we will move the elements and pad the zeros at the end, or you can use two pointer as well. So let's first understand how we can solve this problem using a copy array. Let's say what we can do is we have elements 1, 2, 0, 1, 0, 4, 0. Let's say we have these array. What we need to do is move these particular zeros to the end. So one logic can be create another dummy array, let's say new array, and what we can do is iterate towards the item. First we move towards first elements. Is this a non-zero item? Yes it is. So we move towards the new array and move towards another element. Is it a non-zero element? Yes it is. Then add it to the new array. Is it a non-zero element? No, it is a zero element. So we will skip this one and move to another element. 1 is a non-zero element, so we will add here. Similarly, 0 is a zero element, so we will skip this part and move towards 4. Here 4 is a non-zero element, so what we need to do is add this particular value at the end. And once we iterate towards all the non-zero elements, what we need to do is pad these zeros at the end. So there are 3 zeros, so we will pad 3 zeros at the end. So this is the one way of solving problem. Basically what we do here is move all the non-zero elements into new array, and at last what we can do is add the zeros at the end so that the array and the new array would have same length. So we can solve this problem. Let's see a simple pseudocode to solve this problem, and then we will move towards the second solution. So to solve this problem, what we can do is, let's say we have an array which contains some elements, and we will have new array, and what we can do is iterate towards all this element. I will be using a simple for loop. Let's say for I is equals to 0, I is less than arr dot length and I plus plus. Then what we can do is, if arr of square bracket I is not equal to 0, what we need to do is push arr of I into new array. So we'll push the values to the new array. We can do this, and up next this will move towards or iterate towards all non-zero elements, and once this get completed, what we need to do is fill the zeros. For example, in this case 1, 2, 1, 4 was added here initially. The remaining 3 places needs to be filled up. So what we can do is create another loop which starts from the length of the new array. Let's say new array dot length, and we'll iterate till the array length matches to arr dot length, and we can do I plus plus. Then what we will do here is push 0 into new array. So by this way we can solve this problem. Let's take another example to understand this particular solution, which is 1023 0401. So 1 0 2 3 0 4 0 1. So according to our code, what we'll do is first iterate from first element. Is it a non-zero element? Yes, it is a non-zero element. Let's say it is ARR and it is new ARR. So if it is a non-zero element, we add to the new array, and again on iteration, 0 is a zero element, so we will skip this one and move to second one, push 3 is a non-zero element, push here. 0 is a zero element, so we skip this and push 4, and similarly 1 here. Once this particular loop got ended, what we can do is iterate towards here. Now what we need to do is add zeros till the end. The length of this particular array is 1 2 3 4 1 2 3 4 8. This is currently 5 only, then 3 are remaining, so we will pad 3 at the end here. So this loop will pad 3 at the end, and the original length and the new array length will match. But there are some problems in this particular case. Some of the problems are we are using a new array here, so space complexity comes into case as we are using new array. So our space complexity will be O of n, and our time complexity is O of n. So what we can do is by iterating through the same array using 2 pointer, we can drop this space complexity of on into o1. We don't need a separate array. So let's see how we can solve this problem. So second way of solving this problem is using 2 pointer. So if you don't know about 2 pointers is a very popular way of solving problem in any arrays. So what we will do is start with 2 pointers and move these pointers according to the condition, and it will help to solve the problem with less time complexity. So let me remove this. So to understand this problem, let's consider an array. So here's a simple array with 8 elements. Let's say it is ARR, and it contains elements like, copy of this, see. So we will need multiple steps. I think this will be enough. So let's populate some of the values here. Let's take this example only. We have 1 0 2 3 0 4 0 1. So to solve this problem, what we can do is using 2 pointers, what we will do is whenever we encounter any 0 value, we will swap 2 elements. For example, in this case there are 2 elements here. In case of if we encounter any 0 before a non-zero value, what we will do is swap these 2. So what we can do is instead of this, we can place 2 and 0 here and update the pointer as well. The pointer will move to here, and whenever we encounter a non-zero value before encounter a 0 before a non-zero value, what we will do is swap these 2. So instead of 0, there will be 3. Instead of 0, it will be 0, and again we update this particular counter, or you can say pointer, and we will swap this value. So 0 will be 4 and 4 will be 0, and the pointer will move towards here, and we move the 0 by 1 and 1 will be 0. By this way we can move these zeros at the end. Let's see how we can solve this problem. So basically what we will do is use 2 pointers and move the non-zero elements towards the front. So let's reset this once again. Let us consider this is the initial step which we have this array. So what we would do is start with 2 pointers. One is the index pointer and another is let's say 0 pointer. So 0 pointer is represented by this kind of symbol, and normal pointer is represented by this kind of symbol. So what we will do is first we start with the elements and check if it is a non-zero value or not. In this case the pointer is pointing towards 1 is a non-zero value, so what we need to do is swap. Currently these both are pointing to the same variable, so swapping would result same, so 1 will be no change here. Then what we will do is move the cursor or the pointer, and 0 pointer will remain the same. So now we will move both this particular pointer, because this was a non-zero value, we don't need any operation here, so the pointer will move towards here. So our initial pointer is here, 0 pointer is also pointing here. So whenever we encounter a 0 value, what we need to do is move the pointers towards another element. So on encountering 1, what we will do is move the pointer towards here. So whenever we encounter, now is the case where pointer is pointing towards a non-zero value and the 0 pointer is pointing towards 0 value, we perform swap operation. So these two needs to be swapped. What we need to do is 1, 2, 0, other values remains the same. Then what we need to do is update the 0 pointer as well as the original pointer here. So 0 pointer will be here, original pointer will be here. Now again, the original pointer is pointing towards non-zero value and the 0 pointer is pointing towards 0 value. So we need to perform swap operation. Now on swapping, what we will do is 1, 2, 3 and 0. We will update the 0 pointer as well as original pointer. 0 pointer will move here and original pointer will move here. Rest value remains the same. So pointer is initially pointing towards the non-zero value, 0 value. So what we need to do is simply move the pointer to the next element. So we will move towards this element. The pointer is currently pointing towards non-zero value and we have a 0 pointer. What we need to do is perform swap operation between these two. So what we can do is replace these two values, interchange these two values. So 4 will become here, 0 will become here. Then what we can do is update the 0 pointer to here and increment the original pointer as well. Original pointer moves to here and we can see original pointer is pointing towards 0 value. So we can simply update this particular pointer to a new element. So this will point to here. So what we can do is replace or interchange these two values. So after interchange, it will look like 1, 2, 3, 4, 1 and other 0 will be padded here. So by this way, using one array only, we can solve this problem. So again, once again understanding this particular problem, initially we will have two pointers pointing on same location. If it is a non-zero value, we will update the pointer, update a pointer to another location. If the original pointer is pointing to 0 value, what we need to do is update that particular pointer to next index. And if the original pointer is pointing towards non-zero value, we will perform swap operation. Then what we will do is repeat this step furthermore. Let's take another example to understand this particular problem. We have is 120 104 20. So let's say we have 120 1040. Let's say. So to solve this particular problem, what we can do is start with the initial pointer. Two pointer will be pointing here. As they both are pointing towards a non-zero value, so we will update our pointer 1040. So the pointer will move here, and after moving the pointer here, again it is pointing towards a non-zero value, so we don't have to perform any operation here. So we will update the pointer once again. Now we move towards another element, which is 0 value. Here as it is a 0 value, we need to point the 0 pointer as it is and update the original pointer. So what we will do is update the pointer for the original pointer only. 0 pointer will be pointing here, original pointer will be here. Whenever original pointer is pointing towards a non-zero value, we will perform swap operation. So if we perform swap operation between these two, 1, 2, 1 will be here, 0 will be here, and last value remains same. Once we perform swap operation, we will update both the 0 pointer and the original pointer. So 0 pointer will point towards this and original pointer will point towards this. Here original pointer is pointing towards a non-zero 0 value, so what we need to do is update this pointer. So this will be something like 0 pointer will be pointing here, original pointer will be pointing here, and whenever original pointer points to a non-zero value, we will perform swap between these two values. So this will be 1 2 1 4 0 0 0. And again what we will do is update the 0 pointer to next value as well as update the original pointer to this value. And as soon as this original pointer moves to last element, the loop will end automatically. So this is how we can solve this problem using two pointer. So to solve this problem, let's see how we can write code for this. So we will need to have two pointers. So one pointer will be nothing but the index of the for loop, and to track another zero pointer, what we can do is let's say we can create something called zero index variable. So let's create a variable. Let's say zero index is equals to, let's say 0, and we will have a for loop. I is equals to 0, I is less than arr dot length I plus plus. Then what we need to do is, whenever the index points towards a non-zero value, so if arr of I is not equals to 0, what we need to do is perform swap operation between 0 index and the arr I. So what we need to do is swap arr of I with arr of 0 underscore I. This will perform swap operation, and at the end of this particular loop, the zeros will be moved towards n. So this will be done. So how this will work is, start with the first element is a non-zero value, so it will perform swap. 1 will be swapped with 1, which will return same result. Then 2 will be swapped with 2, it will return same result. Whenever we encounter 0, only the original pointer gets updated, perform swap, 1 will move here. Similarly, this step follows, and we can solve this particular problem. So let's see how we can implement this code using Python as well as JavaScript. So let's first start with the Python code, and we will move towards another solution. So let's first solve using first way, which is using another array, and another is using two pointers. So first, if you use another array, what we need to do is create a new underscore arr, and we need to reiterate towards the array. So to get the index, for familiarity with other languages, for I in, we can do a range function over len of arr, which will iterate towards all the elements, and we do print of arr square bracket I. Let's quickly cross check this, and it will iterate towards all the elements. So if we use another array, what we need to do is, if arr square bracket I is not equal to 0, what we need to do is, we can use only not equal to here, push the values. In case of Python, we called it append arr square bracket I. Let's print and check the value of new arr. It would result in 1 2 3 4 1. 1 2 3 4 1. Again, what we need to do is append 0 at the end. So what we need to do is create another for loop for I in a range. This time we can send the starting value as well, which will be len of new arr and len of arr and new arr dot append 0. Add a semicolon here, and if we test this, it will be 1 2 3 4 1, and 3 zeros will be appended at the last. So by this way, we can solve this problem using another array. Again, this is not the best optimized solution, as we are creating another array here. So let's move towards another solution, which is using two pointers. So to use two pointers, what we need to do is create another index that would keep track of zeros. So let's say its name is 0 index, which is equals to 0, and we need to iterate. Let's quickly copy these. This will iterate towards all the element. If condition still remains the same, if arr of I is not equal to 0, we need to swap them. To swap in Python, there's a basic easier way. So what we can do is arr square bracket I comma arr square bracket 0 index is equals to arr square bracket 0 index comma arr square bracket I. So this will do swapping in Python. This is a easier way, or you can use the temporary variable let temp equals to store the value in it and perform swap operation as well. Currently I am moving towards using this method only. So what this will do is swap the values, and if condition swap, I think this must do the solution. Yeah, so if this condition matches, what we need to do is update the 0 index as well. So finally let's print the original array because we are not using extra array here. So if we run this, we will still get the same answer. So what we have done is, if a square bracket I is not equal to 0, we have performed swap and increased the 0 index as well. Only if we have swapped the values and the 0's index needs to be updated, and this will give us the result. So this is a very simple problem, comparatively easier problem, but for the beginners it might be a new thing. So let's solve this problem using JavaScript as well. So in JavaScript as well, we will use two methods, using another array and using 2 pointers. Let's create a new array, empty array, create a for loop, I is less than arr dot length I plus plus. Then if arr of I not equal to 0, what we need to do is push the value in a new arr, push arr square bracket I and console log new arr. This should result in 1 2 3 4 1. We need to pad zeros at the end, so we can simply copy this, paste here. Starting point will be new arr dot length, and we need to push 0 here. Let's save this, run this. Okay, new arr dot length, my bad. Let's run this. 1 2 3 4 1 and 0 0 will be padded at the end. So this, by this way we can solve using a separate array. Again, more optimized solution will be a 2 pointer. So to create a 2 pointer, you can reuse this code. We will iterate towards let I is equal to 0, I square bracket less than I, and what we need to do is, if this condition matches, we need to perform swap here. So if you know about destructuring in JS, you can use that as well. Let's first create a 0 index here as well, and do arr square bracket I comma arr square bracket 0 index equals to square bracket arr square bracket 0 index comma arr square bracket I, and if this condition is true, we will increment the 0 index. So let's try logging the arr here. I think this should work. 1 2 3 4 1 and 0 is appended at the last. So what we have done is, if the condition is not equal to 0, the pointer is pointing towards a non-zero value. This line of code basically does swap operation, and we have incremented the 0 index to ensure where the front 0 is to track that pointer, and the other values are swapped, and this would result in something like this. So this was a solution, comparatively simple solution, but maybe asked in your interviews and to test your logic. So very important question, you can practice at your own. Not only watching the videos, you need to implement it in your own. Solve the code, you will encounter more errors, and then you will be learning these. So thank you for watching this video. See you on our next video.